Hello, airfoil makers. You should have this as your screen if you followed all the directions for Java security. And the next thing you need to do is you need to set up all the defaults. So click on the flight tab. We're going to set the wind tunnel to 50 miles an hour. And so that's what we want our simulation to be. For altitude, you're going to have to Google the altitude for Lafayette, Colorado, and find out what that is. I'm going to say 5,000 feet. I know that that is not correct. Make sure you put in the correct altitude. And every time you type in a number, you have to hit the enter key um, to make sure that it actually accepts that. The last thing you need to change is specify air temperature and pressure, because air temperature and pressure, as we learned, also impact the coefficient of lift and the actual lift value. So to find the air pressure in pounds per square inch, we're going to find the weather for Lafayette, Colorado. So I've done a quick search for Lafayette weather, and what I found in the past is sometimes people click the wrong state. So I'm going to choose Louisiana because it should be a little bit different, at least in pressure, because they're a mile lower in altitude than we are. So their pressure says 30.11 inches. That's in inches of mercury. And based off this, we need to do it in pounds per square inch. So we need to convert. So we'll open up a new tab, and we're going to say inches of mercury, Hg, to PSI. And there should be a sweet little calculator that comes up, converts right here. So we had 30.11 inches of mercury. We want to convert that into PSI, and that's what we get. So again, it's probably going to be less for Lafayette, Colorado, but I'm going to copy that and I'm going to put that in right here. And then, whoa, it copied a whole lot of numbers. As far as temperature, room temperature in our classroom, which is where we're going to run this, is probably around 70 degrees Fahrenheit. Now, make sure that you hit the enter key for each of these, and I didn't do that, so it didn't set. And I'm going to change this to 70. And so everything is preset for flight right now. Again, it's really important you hit the enter key after each one, otherwise it will not remember it. Now size. For our airfoil, we're going to make this thing set to 4 inches. So in feet, 4 inches is 0.33, hit enter. And span, same thing, 0.33, hit enter. So we're going to have a chord and span of 4 inches in both directions. And if we click find, then we should be able to see it. The last thing you have to do is move on to shape. So at the bottom of the assignment, it shows a table starting with minus 20 degrees. And you need to figure out what the lift and drag and lift to drag ratio is from minus 20 in 5-degree increments to minus 15 and so on and so on. But before you do that, I like to set mine at 0. You can play around with the camber, you can play around with the thickness, and if there was a particular airfoil that you liked, then you can choose that. This is we probably don't want to use these as our options. We want to keep it as an airfoil. And if you make it too thin, it's going to be really, really difficult to cut out of styrofoam. So keep that in mind, that having a little bit, a moderate camber, something that's percentage-wise around 10 or greater, is going to be a lot easier to cut. However, if you want to go thinner, then have at it. So that should be all that you need to do. And then once you collect this data, then you're going to graph this.